All right, this is grade 6, unit 3, lesson 4. And in this lesson, students are going to be converting units. In fact, let's go to that slide. Students are going to be converting units. And the thing is, in 4th and 5th grade, students were converting units. In 4th grade, they were doing it through multiplication. 5th grade, they started to do it through division. But in both of those cases, they were doing it within the same units. In this lesson in 6th grade, students are now going to be converting between units, both through multiplication and division, but from an idea of ratios and equivalent ratios. And so that's why we're doing this converting units. The focus isn't on converting units. The focus is using converting units as the context for understanding equivalent ratios and how to use equivalent ratios to essentially solve proportions. So let's get started on this. And we're going to start with a warm-up, and the warm-up is, find the values mentally. And so we don't want students to kind of convert 1/4 times 32 over 1, and we don't want students to do all that fancy work. We just want them to use logic. And the idea is saying, okay, 1/4 of 32 basically means 4 into 32 is 8 times. Because we want students to recognize this idea of, if we have 32 and we want to cut it into 4 pieces, how many pieces is each of those pieces going to be? And that's the kind of thinking that we want students to be doing for all of these, and using logic. Once we know 1/4 of 32, then we can find 3/4 of 32, because all we have to do is triple it. And then 3/8 of 32. How does 3/4 relate to 3/8? And students are going to use these relationships. This is just a beautiful problem string that allows students to use each previous answer to get the next subsequent answers. Teachers, this is a fantastic warm-up. Totally don't skip it. All right, number 2, activity 2. Elena and her mom are on a road trip outside the United States. Elena sees this road sign and it says maximum 80. And the idea is 80 what? And Elena's mom is driving 75 miles per hour when she gets pulled over for speeding. So how is that even possible if the maximum is 80, but the mom's driving 75 and yet she gets in trouble for speeding? Well, the police officer explains that, and this is a true story, 8 kilometers is approximately 5 miles. So maybe they're driving it says they're driving on a road trip outside the United States. See, that's the key right there. Maybe they're driving in Canada. And this is not 80 miles per hour. This is probably 80 kilometers per hour. And so the police officer explains that 8 kilometers is approximately 5 miles. So let's answer some questions. We're going to answer how many kilometers are in 1 mile. And then we're going to answer how many miles are in 1 kilometer. So a couple of unit rates. So what I'm going to do is I'm going to create a table. And that table is going to have 8 kilometers is equal to 5 miles. So let's do that. So we got kilometers, we've got miles, and we're starting off with the premise that 8 kilometers is equal to 5 miles. And we want to know how many kilometers are in 1 mile. So we have, I want it to be in black. We want 1 mile. And so if we want 1 mile, what are we going to have to do to our previous ratio? What are we going to need to do to this ratio to scale down so that we only have 1 mile? We're going to divide by 5, and that's going to give us 1 mile. 5 divided by 5 gives us 1. Which means we're going to divide over here. 8 divided by 5. And 8 divided by 5 is not a tidy number. So I'm just going to write it as 8/5. But for the people who like decimals, I'm going to say that answer is 1.6. So every 1 mile is equal to 1.6 kilometers. All right, so there's your unit rate right there. And then the second one is how many miles are in 1 kilometer. So we want the other unit rate. And so I'm going to do that in black. In this case, we want 1 kilometer. So the idea is, well, how do we go back to that original rate, that original ratio up there, and how do I turn the 8 into a 1? Well, I'm going to scale by dividing by, in this case, I'm going to divide by 8. So I'm going to divide by 8. So 8 divided by 8 gives me 1, which means over here on the right side, I'm going to do 5 divided by 8, which is not a tidy number, so it's 5/8. 5 divided by 8 is 5/8. But if you want to have the actual decimal, it's 0.625. All right, and there's our 2 unit rates. Now, it says if the speed is 80 kilometers per hour, and Elena's mom was driving 75 miles per hour, so we have 80 kilometers per hour and we have 75 miles. Was she speeding? Well, probably, because that's why the police officer pulled her over. But the question is, by how much? So what I'm going to do is I'm going to go up here and I'm going to get that table and I'm going to just kind of bring it down here. So I'm going to copy that. I'm going to bring it down here because that's the miracle of technology. Now, somehow I need to connect kilometers and miles. And so I want to know if 8 kilometers per hour is equal to 5 miles per hour. I want to know if she was driving, if mom was driving, let's see, 75 miles per hour. I want to know, how much was she speeding? What is that equal to in kilometers? Because she's not supposed to go over the 80 kilometers right here. So I can see a couple of ways we could scale this. So I'm going to zoom in here. I can see that we could either take the 5 and multiply by something to get 75. That's kind of handy. Or I could take the 1 and multiply by something to get to 75. So 2 different ways that we could scale. In this case, I'm just going to avoid the decimal and I'm going to use the 5 and I'm going to say, well, let's see, 5 times 15. So 5 times 15 gives us 75. So I'm going to do the 8 times 15 and that's going to give us 120. Whoa, 120 kilometers. So she was only supposed to be going 80 kilometers per hour, but she was actually going 120 kilometers per hour. So she was definitely speeding, and she was going 40 kilometers per hour too fast. Now that I think about it, I think I put KMH up here. Kilometers. It's kilometers per hour. KPH up there, not KMH. I was thinking KM as in kilometers, and then, okay, anyway. I guess I could have done kilometers per hour like that. All right, I'm thinking on the spot here, folks. All right, veterinary weights. So a veterinarian uses weights in kilograms to figure out what dosages of medicines to prescribe for the animals. And here's the key, and this is a true story as well. 10 kilometers, for every 10 kilometers, there's 22 pounds. So from kilometers and kilograms and pounds, 10 kilograms is equal to 22 pounds. All right, so there's our ratio. Now we're going to calculate each animal's weight in kilograms. So let's start by making our table, because tables rule. So we've got kilograms, kg, and we've got pounds, lbs. All right, and we know that 10 kilograms is equal to 22 pounds. And we want to know, we have an 88-pound Labrador. How heavy in kilograms is that Labrador? And so that's not terribly hard. We just multiply by 4, and we get 40 kilograms. All right, so we know that the Labrador weighs 40 kilograms. And now we want to know Spot the Beagle. Spot the Beagle is 33 pounds. So in this case, I'm going to kind of create a little space here, and you'll see why in a second. And we know we want 33 pounds. So what are we going to do? So somehow we have to turn this initial ratio from 22 pounds into 33 pounds. So I see a handy dandy thing. We can immediately take that initial ratio and scale it by 2. Dividing by 2, that gives us 5 kilograms is 11 pounds. And now I can multiply by 3, scale it up by 3, and I get 15 kilograms. 15 kilograms. And then Bella the Chihuahua weighs 5.5 pounds. Oh, cute. Okay, so 5.5 pounds. And I don't need it. This one's not terribly difficult. So if Bella weighs 5.5 pounds, how many kilograms? Well, I could see a relationship already. I can see that 11 and 5.5, they're related. They're related by a factor of 2. That 11 divided by 2 gives me 5.5. That means 5 divided by 2 gives me 2.5, because we just cut it in half. And so there is Bella. Bella weighs 2.5 kilograms. Oh, cute. So a certain medication says it can only be given to animals over 25 kilograms. How much is 25 kilograms in pounds? All right, so we're going to go back and let's make that table again. So kilograms and pounds, LBS, and we're going to start with that initial ratio of 10 kilograms is equal to 22 pounds. And somehow I need to turn that 10 kilograms into 25 kilograms. And that's going to tell me how many pounds that is. All right, so there's my table. It's an ugly table as all heck, but that's okay. So how do we turn, it's almost like a game. How do we turn a 10 into a 25? Through multiplication and division. There's lots of ways. In fact, there's an infinite number of ways that we could do this. So one way that we could do this is I could see that, well, if I scale down by 2, that gives me 5 kilograms and 11 pounds. And then I can scale up by multiplying by 5. Multiply by 5, and that gives me 55 pounds. So what did I do? I started with my initial ratio. 10 kilograms is equal to 22 pounds. I scaled it down to get to 5, and then I scaled it up to get to 25. Totally not the only way to do this. We could have done this other ways. In fact, let's do it real quick. I could have started with, okay, let's do that again real quick, because I want you to see this. This is so stinking cool. When we start with 10 and 22, and I want to get down here to 25, another way I could have done this is I could have like multiplied by 5. Multiply by 5, that gives me 50 and 110. And then I could have divided by 2. I could have divided by 2, and that would give me 55. They both give me the exact same answer, but I did it in using kind of like different recipes, so to speak. This recipe was divide by 2 times by 5. This recipe was like times by 5 divide by 2. I guess same numbers, isn't it? Okay. Cooking with the tablespoon. This activity right here is optional in the lesson, so I'm not going to talk about this, but you could do it. It's more of the same. Just make a ratio and then make a ratio table and then move on, because here is your given ratio. 1 cup equals 16 tablespoons. And really, I think the highlight of this is to point out how absurd the standard system of measurement is. Metric system, way easier. All right, so there's our lesson summary. Once again, we could be using double number lines. I'm a tables kind of guy, so I'm going to keep using tables, but we could absolutely use number lines. Nothing wrong with number lines. All right, let's jump into some practice. It's been about 15 minutes. All right, so Priya's family exchanged $250 for 4,250 pesos. Priya bought a sweater for 510 pesos. We want to know how much did the sweater cost in dollars. All right, so what they're doing is they're guiding us towards a nice solution system. All right, and kind of like a recipe, like I was saying. So it looks like first thing they did was divide by 10. So we're going to divide by 10, and we get 425. Then it looks like they divide by 25 to get down to 1. So we're going to divide by 25. And we get 16, 17. We get 17. And then we're going to multiply by 3, scale by 3, scale up by multiplying by 3. And that gives us 51. And then I can finally see over here, to get to our destination of 510, we multiply by 10. So I'm going to multiply by 10. And I find out that that sweater cost Priya $30 right there. All right. So the idea is kind of following a recipe and knowing that well, in this case, they told us what recipe to use, but knowing that in any kind of problem where you're trying to take one ratio and turn it into another ratio, there are an infinite number of recipes that would work. So you don't have to worry about finding the recipe. Just use a recipe, not the recipe, a recipe. So there's 3,785 milliliters in 1 gallon, and there's 4 quarts in a gallon. For each question, explain or show your reasoning. So how many milliliters are in 3 gallons? So we know, so there we go. We were told that milliliters and gallons, that there are 3,785 milliliters in 1 gallon. And we want to know, what is that going to look like for 3 gallons? So in this case, the recipe, not terribly difficult. We just triple the gallons. So we're scaling by, by multiplying by 3, in which case, in this case, we're going to multiply by 3. And I'll let you grab your calculator and multiply that. But now it says how many milliliters are in a quart. So we know that there's 4 quarts in a gallon. So really what they're saying is, I want to know how many milliliters are there in 1/4 of a gallon. There's 4 quarts in a gallon, so 1/4 of a gallon. So what's my scale factor? What am I going to scale? I'm going to scale by dividing by 4, because that's how you turn a 1 into a 1/4. So what am I going to do on the left side with the milliliters? I'm going to divide by 4. So I'm going to do 3,785 divided by 4. And whatever that answer is, that's your answer right there. So number 3, Lynn knows that there are 4 quarts in a gallon. Once again, there's our magic thing, 4 quarts in a gallon. She wants to convert 6 quarts to gallons, but cannot decide if she should multiply 6 by 4 or divide 6 by 4 to find her answer. What should she do? All right, so we could use a table on this. And so the idea is, I have, let's see, quarts, and I have gallons. And I know that I have 4 quarts in 1 gallon. And I want to figure out, how do I convert 6 quarts into gallons? So what am I going to do? Boy, we got a couple of options here. But I see that, how do you turn, let's see, right here, how do you turn a 4 into a 6? Well, interestingly enough, the way you turn a 4 into a 6 is you're going to, let's see, you're going to multiply by 6/4. So 4 times 6/4 gives me 6. So what does that mean? That means we are dividing 6 by 4. That's what that 6/4 is. Another way to see it is you can say, hey, look at this. 4 divided by 4. 4 quarts gives me 1 gallon. So 4 divided by 4 gives me 1 gallon. So 6 divided by 4 gives me how many gallons I'm supposed to have. And 6/4 is equal to 1.5. Oops, 1.5. 1.5 gallons. All right, I'm going to make that a little smaller, get it out of my way. There we go. And then Tyler has a baseball bat that weighs 28 ounces. Find this weight in kilograms. And remember that the unit rate, or the conversion rate, so to speak, is 1 kilogram is equal to 35 ounces. All right, so if that is our starting ratio, so we have kilograms and ounces, and we have 1 kilogram is equal to 35 ounces, and we want to know right here, what is 28 ounces? And so I just create a whole series of rows. I don't know if I'm going to need them all. That's how I do it. And I have to think about, how is 35 and 28? How are they related? And I know that there's a number 7 related, because I know that 7 times 5 is 35 and 7 times 4 is 28. So I see that there's a number, there's a factor of 7 that's related in some fashion. So what I'm going to do is, using my little strategy here, using some, I don't know, power of thinking, is I'm going to divide by 5. Because if I could divide, and so I'm going to scale down by dividing by 5. So 35 divided by 5 is 7. And 1 divided by 5 is 1/5, which is the same thing as 0.2. All right, so there's my answer for kilograms. So 7 ounces is equal to 0.2 kilograms, or 1/5 of a kilogram. And now I can say, oh, I get it. 7 times 4 is 28. So what am I going to do over here? I'm going to multiply it by 4. And I know that 1/5 times 4 is 4/5. And that's the same thing as 0.8. So 0.8 of a kilogram is 28 ounces. All right. Little bit of review here. Identify whether each unit measures length, volume, or weight. And so miles is length, cup is volume, pound is weight, and I'm going to let you just continue identifying the length, which ones are lengths, which ones are volumes, and which ones are weights. More review here. A recipe for trail mix uses 7 ounces of almonds with 5 ounces of raisins. Almonds and raisins are the only 2 ingredients, so there's not going to be a trick question. How many ounces of almonds would be in a 1 pound bag of trail mix? So how many ounces in a pound? I think it's 16 ounces in a pound, 32 ounces in a pound. I don't remember. So let's look this up, because to be honest, I don't remember. So let's see. Let's go here and we say, how many ounces in a pound? 16. All right, I think I was going to remember that. Good. So now that I know that there's 16 ounces in a pound, let's go back. And it would have been nice if I knew that. So 16 ounces in a pound. So we're going to make our handy dandy table. And let's zoom in here. Handy dandy table. And we want ounces and pounds. So ounces and pounds. You know, actually, on this one, I probably won't make a table. You know, on this one, I think I'm going to use it as a almonds and raisins, and I'm going to do a tape diagram. And we got the ratio is 7:5. So I need 7 units. 1, 2, 3, 4, 5, 6, 7. and then 1, 2, 3, 4, 1, 2, 3, 4, 5, and then 5 units for the raisins. All right, there's my ratio of 7 almonds to 5 raisins, so to speak. 7 ounces of almonds, 5 ounces of raisins. And how many ounces of almonds would be needed in a 1 pound? So the idea is all together, this equals 16 ounces. And so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these 12 units, and I'm going to erase all that, is equal to 16 ounces. So that means 1 unit is equal to 16 twelfths ounces, which reduces to, let's see, 8 sixths, which reduces to 4 thirds. So each of these units is 4 thirds, 4 thirds, 4 thirds, 4 thirds, 4 thirds, 4 thirds, and 4 thirds. And so we have 7 of them. So 7 times 4 thirds gives us 28 thirds, which is 9 1/3 ounces. So we need 9 1/3 ounces of almonds to make a 1 pound bag of trail mix. And our last question. An ant can travel at a constant speed of 980 inches every 5 minutes. How far does it travel? And all that sort of stuff. So let's do it. Here's our table. We've got inches over here. We've got minutes over here. And let's insert 980 inches in 5 minutes. How far does it travel in 1 minute? All right, so how do we convert? We want to know 1 minute. So what's our scale? Our scale rate is we're going to divide by 5, which means we're going to divide by 5. And that answer is, let's see, 196. And then, so that's that answer. And then at this rate, how far can the ant travel in 7 minutes? So now we want to know 7 minutes. So what are we going to do? Well, our scale factor is multiply by 7, which means our multiply by 7. And your answer is whatever the heck 196 times 7 is. And that wraps up, let's see, grade 6, unit 3, lesson 4, where we were using unit rates and ratios and all that sort of stuff to convert between unit measurements, between measurement systems. But the real focus wasn't conversion. The real focus was on using ratios in a strategic way. So folks, don't forget to subscribe and have a great day.